Okay, so we're on page 566, so I'm sitting here looking at an empty page, but that's okay. I'll read what we have here. An algebraic expression consisting of one or more terms that look like either a real number or a real number times a variable raised to a whole number power is called a polynomial. In this lesson, we've studied operations on polynomials, combining polynomials using addition, subtraction, and multiplication. So let's summarize what we've learned. So in questions 1 through 4, they want us to simplify each expression. And so we're going to use the order of operations, and we're going to remember that multiplication always comes before addition or subtraction. The distributive property is needed when multiplying a number or variable by a sum or a difference. So when subtracting a polynomial, don't forget to subtract every term of an expression. That's what the parentheses are there for. So I'm going to pause and write down all of our problems. Okay, the problems are written down. So number 1 is just straight addition. It's probably the easiest of all the problems that we'll do. Really, the parentheses are there for no other reason to say, hey, I'm adding two polynomials. So I'm just going to drop the parentheses because they don't add anything to our situation. Now we're going to combine like terms. These x squareds are like terms. 3x squared plus 2x squared is 5x squared. These x's are like terms. 3x minus 3x means I have no more x's. And then the 5 and the minus 10 are like terms. So 5 minus 10 is negative 5. So I should have 5x squared minus 5. On number 2, we are subtracting this polynomial. The first polynomial, that parentheses really doesn't do anything for us other than say there's a polynomial. But they want to remind you we are subtracting every single term. So I'm subtracting an x squared. I'm subtracting a negative 2x, so that'll be plus 2x. I'm subtracting 7, so I have minus 7. All right, so here are my x squareds. I have 5x squared minus x squared, which means I have 4x squareds. I have a 3x plus a 2x, which means I have 5x. I have a 2 minus 7, which means I have a minus 5. So I am done. All right, on number 3, we have to use the distributive property first. So that will give me 3x squared plus 9x plus 15. Then I have a positive 2. It's going to be distributed to each term here. So plus 2x squared minus 6x minus 20. So again, adding like terms, 3x squared plus 2x squared is 5x squared. A 9x minus 6x gives me a plus 3x. And the 15 minus 20 would give me a negative 5. Okay, lastly on this page, I have a 2 times 3x squared plus 4x minus 5, and then negative 3 times 4x squared minus 5x plus 1. Okay, when I distribute over here, I need to remember I'm distributing a negative 3 there. All right, so let's get to it. So distributing the 2, I have 6x squared plus 8x minus 10. And then a negative 3 times 4x squared is minus 12x squared. A negative 3 times a negative 5x is plus 15x. And a negative 3 times 1 is a negative 3. All right, combining like terms, 6x squared minus 12x squared gives me negative 6x squared. An 8x plus 15x gives me plus 23x. And a negative 10 minus 3 gives me a minus 13. All right, to the next. How exciting. There are words on this page. You probably already noticed that multiplying expressions is more challenging than adding and subtracting them. For that reason, we're going to get some more practice in multiplying and also develop a method to check and see if your result is correct when you multiply expressions. It also works for adding and subtracting, by the way. So they're asking us to perform each multiplication, keeping in mind that our procedure involves multiplying every term in the first factor by every term in the second factor. All right, just to be consistent, what we did on the other page is we had the y minus 5 times the y, and then plus y minus 5 times the 7. Okay, so distributing, that gives me y squared minus 5y, and then I have 7y minus 35. So I only have two like terms here, so let's combine those. Y squared plus 2y minus 35. Okay, let's do the same thing here. Recall that we've got 2x plus 6 times a 3x plus 2x plus 6 times, I'm going to put this in parentheses, a negative 8. Okay, so distributing that 3x, I have 6x squared plus 18x. And distributing that negative 8, I have minus 16x minus 48. Adding like terms, I have 6x squared plus 2x minus 48. Now it says use a distributive property to multiply 2x times 3x plus 4. Well, that'll be easy enough. I have 6x squared plus 8x. So it asked us, does it match a description from question 5? Yeah, because every term in the first polynomial is 2x, and we only had one term there. 2x was multiplied by everything in the parentheses, 3x plus 4. All right, let's move up the screen. Now about checking our answers. Earlier we pointed out that the goal when simplifying is to get another expression that provides the exact same output as the original no matter what input you choose. So if two expressions satisfy that condition, what should the relationship between their graphs be? Well, they would have to be the same. If the expressions are the same, those graphs would have to look the same. So they would look the same. So if you're concerned about whether or not you were right, you could put both of them in Desmos, check out their graphs, and make sure that they look exactly the same. So that's what they're asking you to do in number 8. Okay, so on to page 9. So 9 says our next goal is to multiply the binomial x minus 5 times the trinomial x squared plus 3x plus 4. So they're asking us to multiply x by each term here. So you'll notice that they're doing something a little bit different here. That's okay. I mean to take this up with them next time they edit this particular book. So if I multiply x times every term in that next trinomial, I get x cubed plus 3x squared plus 4x. Now they're asking us to multiply negative 5 by each term of that trinomial. All right, easy enough. So that gives me negative 5x squared minus 15x minus 20. Then it says add all 6 products from parts A and B combining any like terms. So I'm going to go ahead and write what I had in 9A. And I'm going to write what I had in 9B. And I'm going to line up the like terms. So I get x squared minus 2x squared minus 11x minus 20. And then again on 10 they're asking us to use a graph to make sure that they look the same. And of course they should. Now I'm just going to practice again with this did you get it? And I'm going to show you an alternative method for multiplying this binomial times a trinomial. I call it the Battleship Method. Mathematicians actually call it the rectangular array. But usually when I talk to my students about the rectangular array, they have no idea what I'm talking about. But if I ask them if they remembered playing Battleship ever as a child, the ones that did kind of get where I'm going with this. So notice I have a binomial with 2 terms, a 2x plus 1 times a trinomial with 3 terms. And I've made a grid. So I'm going to multiply that 2x times x squared, and I get 2x cubed. So the 1 times the x squared gives me x squared. All right, 2x times negative 3x is negative 6x squared. 1 times negative 3x is negative 3x. 2x times 2 is 4x. And 1 times 2 is 2. Now let's combine like terms. I have 2x cubed Let's look at my x squareds. That gives me minus 5x squared. Let's look at my x's. I have plus x and then plus 2. That can work for any number of terms in your polynomials that you're multiplying by. So a lot of my students like to do this with the binomial times the binomial. If you're interested, check it out. But I generally will do this method if I have to multiply by anything more than two, something with anything more than 2 terms in it.